So this is a ledge water bot made for simulating tub-like shapes with sharp ledges like this. After it collects a beeper, it's originally facing south. If front beeper is clear, which checks that if there's a wall or a beeper in front, it continues to move. When it hits the bottom wall, if there is a wall or front is not clear, it turns west and checks the row. To check the row, it turns west, and then for every one spot it moves, it turns south and checks if the front beeper is clear. If it is clear, it moves and puts a beeper and recollects. If not, it turns west again and continues to check the row. Eventually, if facing west and there's a wall in front, it means that it has hit a wall and the whole row below is filled. So it turns east and walks all the way back to the wall and places a beeper to start a new row. Because of time constraints, I couldn't show you all the maps, so I just showed a screenshot of the before and after. So for the steep hill water bot, it's made for simulating kinked shapes with sharp ledges, and the difference in algorithm is that it needs to accommodate that every time it hits a wall, it doesn't mean the start of a new row. So every time when it checks the row, it must check that there may be more at the bottom every time it checks the south. So if there is, in this case, it'll move all the way down again. And then accordingly, it puts the beeper. For middle water bots, the water bots start in the middle and flow out from both directions. So when it is instantiated, a home X and Y coordinate is stored. And after it picks up the beeper, it moves all the way to the bottom and stores the bottom Y value. It puts the first beeper and recollects. It repeats this, but this time when it hits the bottom Y value, and while next to a beeper and the front is clear, it moves west. By doing this, it checks which spot is clear of beepers on the left side and stores the X value of that. And then it does the same for the facing eastward on the right. It checks the right side and stores the empty X value. Then the algorithm compares both the empty X value on the left and right, and whichever is closest to the center Y the center X that we stored initially, the water bot will put the beeper there. When the row fills up, the bottom Y will increase by 1, and the process repeats again. So for the extension, I did threading to simulate a larger flow of water. And in this case, there are now 2 water bots transporting the water droplets. I basically did this by implementing runnable on middle water bot and creating a new method called run, which is actually the exact same thing as flow.